Hello, welcome to SPMM Revision on Demand. In this podcast, I will discuss the issue of choosing statistical tests, especially univariate tests. Whenever you are asked to choose an appropriate statistical test for a research scenario, there are 5 questions to answer before you choose a test. You have to answer these 5 questions using the information that you were given in a question. Firstly, how many variables of interest are there? Secondly, how many groups are we comparing? Here, a group refers to a collection of individuals undergoing a single specific measurement of the variable of interest. If the same set of individuals are measured twice on the variable of interest, we can assume that there are 2 groups. Third, do the variables satisfy parametric assumptions or not? As most biological values are normally distributed, we need to assume normality unless it is obvious that we cannot. Fourth, we need to ask, is the same variable measured more than once in the same individual? If it is, then it is likely to be a paired observation. If not, then the observations are unpaired or independent. Finally, on what basis are the groups compared? Is it on the basis of a central value, such as the mean or median, or on the basis of frequency counts arising from categorical data? For example, let's assume we want to compare the weight of 2 groups. If weight is measured in kilogram, then the mean can be compared between the 2 groups. Instead, if subjects are classified as obese and non-obese, the proportion falling into each category can be compared. In this case, we are comparing frequency counts. The possible answers to these 5 questions are shown here graphically. How many variables? In general, a researcher may be interested in either a single variable or 2 variables, bivariate, or multiple variables, multivariate. How many groups? 1, 2, or greater than 2? Can we assume parametric assumptions or not? In general, this refers to the presence or absence of normality, normal distribution in the data. Are we dealing with paired or unpaired observations? 2 observations of a variable from the same individual are more likely to be dependent on each other. But if these are from 2 different individuals, they will be independent. Finally, the question of mean versus proportions. Here, the important issue is the type of data. Are we dealing with categorical data or continuous data? Let's consider the family of t-tests first. Firstly, one sample t-test. Here, only one group is studied, and the mean value is measured. The inference is made in comparison with the population. Next, students t-test. This is also called unpaired t-test. Here, the observations are independent or unpaired. When the mean value is compared, parametric assumptions are satisfied, and there are 2 groups to compare. The non-parametric equivalent of students t-test is Mann-Whitney U-test. Next, paired test. This is used when the observations are paired, when the mean value is compared, when parametric assumptions are satisfied, and when there are 2 groups to compare. The non-parametric equivalent of paired t-test is Wilcoxon rank sum test. This figure summarizes the one sample t-test. One sample t-test is used when you are interested in a single variable, you have only a single group, and you can assume parametric distribution, the observations are unpaired, and you are comparing mean value with the population. Univariate, two groups, parametric assumption satisfied, unpaired observation, comparison of central values such as mean. This can be made using unpaired t-test. Univariate, two groups, non-parametric, unpaired, central value comparison. This can be made using Mann-Whitney U-test. Univariate, two groups, parametric, paired observations, central value comparison. This can be made using paired t-test. Univariate, two groups, non-parametric, paired observations, comparison of central values such as mean. This can be made using Wilcoxon rank sum test. Let's now consider the family of F-tests or ANOVA. One-way ANOVA is used when there are greater than two groups, when parametric assumptions are satisfied, and when the observations are independent or unpaired, and when the mean value, that is a central tendency, is compared. The non-parametric equivalent of a one-way ANOVA is Kruskal-Wallis test as shown here. Then comes repeated measures ANOVA. This is used when there are greater than two groups, when parametric assumptions are satisfied, and when the observations are paired. This is why it's called repeated measure. And when the mean value, that is a central tendency, is compared. The non-parametric equivalent of repeated measure ANOVA is Friedman test. In this figure, we are now looking graphically at the ANOVA tests. Univariate, greater than two groups, parametric, unpaired, central value comparison can be made using one-way ANOVA. The word one in one way refers to its univariate nature. Univariate, more than two groups, non-parametric, unpaired, central value comparisons can be made using Kruskal-Wallis test. Univariate, greater than two groups, parametric, paired, central value comparison can be made using repeated measure ANOVA. Univariate, greater than two groups, non-parametric, paired, central value comparison can be made using Friedman's test. Let's now see some more information about ANOVA family. There are some assumptions for using ANOVA. These are essentially the assumptions for any parametric test, such as normality, equal variances, and independence of observations, as ANOVA is a parametric test. ANOVA stands for analysis of variance. The results of an ANOVA test tells if the groups differ, but it does not tell where the difference comes from among the several groups. We need post hoc tests such as t-test to find the difference. ANOVA can also be used if there are only two groups. So whenever you can choose t-test for two groups, you can choose ANOVA as well. Next set of univariate tests include the chi-square family. Chi-square tests are used to compare proportions frequency counts. This test makes use of 2x2 tables. It uses the ratio of observed to expected frequencies when computing the statistics. If expected frequency is in 20% of the cells, that is, at least 1 out of 4 cells in a 2x2 table falls less than 5, we need to use either Fisher's exact test or Aitz's correction. McNemus test is the paired equivalent of the chi-square test. This is a visual summary of the chi-square. Chi-square test is a univariate test used for both two groups or greater than two groups comparison and used with both parametric and non-parametric conditions on unpaired data whose proportions or frequency counts are being compared. Example, comparing the proportion of responders in active versus placebo treatment. McNemus test is a univariate test used for both two groups or greater than two groups comparison and used with both parametric and non-parametric conditions on paired data whose proportions or frequency counts are being compared. Example, comparing the proportion of relapse in a group before and after initiating a rehabilitation program. Chi-square also helps to study heterogeneity among trials in meta-analysis. You will see more of this in a separate podcast. An important issue that comes up with chi-square test for your exams concerns the concept of degree of freedom. This refers to the number of values in the final calculation of a statistic that are free to vary. Degree of freedom for chi-square is given by number of rows minus 1 into number of columns minus 1. So it's a product of number of rows minus 1 and number of columns minus 1. For a 2 by 2 table, this will be 2 minus 1 into 2 minus 1, which is 1. So the degree of freedom for a 2 by 2 table is 1. Compare the baseline and endpoint weight in the same individuals undergoing a trial of depot antipsychotic. Here, the variable of interest is 1, which is weight. So this is univariate test that we require. There are two groups, people who undergo measurement at baseline and people who undergo measurement at endpoint, though these two groups are made of same individuals. Weight can be assumed to be normally distributed. Each person is weighed twice, so this is a paired observation. This is a continuous measure with central tendency being compared. The attached figure explains the answers for the 5 key questions. The answer is paired t-test. Compare the proportion of responders in two groups, one receiving CBT for 16 weeks and the other receiving interpersonal therapy or IPT. Variable of interest is a single item response, so this is univariate. There are two groups, CBT and IPT. Response is a categorical variable, thus non-parametric. Presence of response in each person is tested only once, so these are independent groups. This is a categorical measure because it's comparing proportions. The attached figure explains the answers for the 5 key questions. Univariate, group 2 or more, non-parametric, unpaired, and it's a frequency count. The answer is chi-square test. Now it's time to ask yourself a few questions. Thank you for choosing SPM course for your revision.